Welcome back to my channel. In the last video, I have discussed about the function y equals to x power 2n. In this video, I'll be discussing about the function y equals to x power 2n minus 1. So it is again this function y equals to x power 2n minus 1. This is again an algebraic function. Specifically, it is a polynomial type of function. So we start with the graph of y equals to x cube. So I would like to ask everyone to check out the video y equals to x cube, graphing the function of y equals to x cube. So if we understand that video, then all the properties of this function y equals to x power 2n is exactly same as this function y equals to x cube. Now, as I have already said that all the properties are same as y equals to x cube. So for n equals to 2, 3, 4, 5 different values of n, we get different types of function. So for example, for 2 we get x cube, then we get the next power for 3 which is x power 5, next we get x power 7. So 3, 5, 7, 9, these are all the odd powers. Now, as the function y equals to x power 2n, we need to divide the real line into three parts. So, one is here. So, now here we should divide it into four parts. So, here is 0, then there is minus 1, then there is 1. So, one part is less than minus 1, which is this part. Next part is this part, which is between minus 1 to 0. Next part is between this 0 to 1. This is 1. And last part is greater than 1. So for these four parts of the real line, we will get four different properties and four different inequalities. Now first, let us start with 1 to infinity part, which is this part here. So here what we are getting, x is less than x cube, less than x power 5, less than x power 7. So all those odd powers are following this inequality. So let me start with an example. Suppose we take the value x equals to 2. What happens? 2 is less than 2 cube, 2 less than 2 power 5 and so on. So obviously this inequality is satisfied in this interval. Now let us see what happens in the minus infinity to minus 1 interval, which is this interval here. So again, let us take an example like this, minus 2. So what happens is that as here we have the odd powers, so each power will get a minus sign, and if we add a minus sign in this inequality here, the sign of the direction of the inequality will change. So it gives this, which is minus 2 cube, minus 2 power 5, minus 2 power 7 and so on. So because of the odd power, all the minus will be here. Okay. So here we get the opposite inequality from the interval 1 to infinity. So minus infinity to minus 1 and 1 to infinity will have completely opposite inequalities. Now let us check the interval 0 to 1. So what happens is in the 0 to 1 interval, again let us take a number like x equals to half, and from here we can see that half is what? Half square. So it should be greater. Again 1 by 2 power 4. Okay, so I am taking here the odd numbers, even numbers. So I must take here the odd numbers like 2 cube, 2 power 5. It still holds. Okay, so 1 by 2 power 7 and so on. So here again we are getting this inequality, x greater than x cube greater than x power 5, x power 7, which is same as this part, minus infinity to minus 1. So 0 to 1 and minus infinity to minus 1, these two parts have the same kind of inequality. Now moving to the minus 1 to 0 part, again due to the power being the odd power, so here again from this inequality we will only get the minus parts. If suppose I take the value x equals to minus half, what I will get? Minus half should be from here should be less than minus 1 power 2 cube, as adding the minus changes the direction of the inequality, and minus 2 power 5 and so on. Okay, so here we are getting this inequality where x is less than x cube, less than x5, less than x power 7. So again what happens is that this part minus 1 to 0 and this part which is 1 to infinity, these two parts have the same kind of inequality. Now if we try to plot the function here, so what happens is that, suppose, so what happens, the in the interval, so let me take it as minus 1 and this one as 1. So from the inequality we can see that here this part, where is this part, and this part will have the same kind of inequality, and this part and this part will have the same kind of inequality. So here the black colored function is the x cube function which we have already plotted, and this one here is the x power 5 function, next is the x power 7 function, and lastly there is the x power 9 function. So in the interval 0 to 1, here in the interval 0 to 1 we can see that the red curve is at the lowest. So here this kind of inequality must hold, x cube should be greater. Similarly here we can see that x power 9 is here, so again x power 9 should be the lowest in the value. However, in the interval minus 1 to 0 we can see that the red curve, which is this x power 9, is at the highest, so it has the maximum value, and same happens after this interval greater than 1, where again this x power 9 function is at the highest position. So we can draw these functions like x power 5, x power 7, x power 9 by using the function x cube as the guide, and here we have already plotted. So these are the graphs of the functions like x power 2n minus 1. In the next video, I'll be discussing about the rational functions like 1 by x. Please like and comment on this video and subscribe to my YouTube channel for more videos. Thank you.